Thanks for inviting me here today, Best. I'm hoping to finish in time, so I'm just going to jump right in. And I'd like to thank the people who contributed to thinking on data infrastructure in life in Australia as well. There we go. So Life in Australia is it's Australia's first probability online panel. And last year we ran on a monthly wave model, though now we've grown to accommodate one survey per fortnight. Currently, we're able to obtain about 8,000 unique completed surveys per month. And it's mostly an online panel, though we have a small fraction of offline panelists who we interview by telephone. This is a brief general overview of Life in Australia's key infrastructure. Of course, not all the detail is there, but on the left, you see we have multiple external service providers, and on the right, playing an overarching role, we have what we've come to see as a orchestration layer, or at least aspires to be. So first, why the pun in the title? Bach's widely celebrated for his orchestral work, though perhaps more widely known for his vocal and keyboard compositions. Life in Australia, not so widely celebrated for orchestration, and certainly more well known for a rigorous approach to probability panels. In the movie Back to the Future, the characters travel to the future, which for them is 2015, which is 2015 is incidentally around the time that orchestration became a big deal with the popularity of Apache Airflow. Life in Australia doesn't use Apache Airflow, and our orchestration is admittedly less sophisticated due to different needs that we have at the moment. So in this talk, we'll travel to our own future, which is around 2015. I'm keeping you engaged as well by making sure you wait for a definition of orchestration, so please be patient with me for that. A premise of this talk is that there's a delicate point at which data problems require data engineering solutions. So what we mean by data problems, let's look at what we strive for. A simple data model promotes reliability and ease of use and shared understanding. But we'd also like to achieve data integrity and consistency throughout the entire data lifecycle, from production to operations and storage and consumption. This gets more complicated when we add multiple interacting services like email servers and survey platforms, member portals and incentive systems. And each of these independent systems have their own logic, and they interact with each other through interfaces that are loosely coupled. Each can be a source of critical data or functionality, and it can each be a critical point of failure. The biggest concern is, as captured by this quote down the bottom, a very famous quote, is reduced complexity. The 2022 book, Fundamentals of Data Engineering, which is by Rees and Housley, offers a picture of the data engineer as a recovering data scientist. In 2010, there was a pervasive attitude that data engineers worked with big data, defined by the 3 V's: velocity, variety, and volume. Data infrastructure in other cases was left to software engineers, or it's taken as a side effect of data science. And as a result, we begin to see a lot of ad hoc and context-specific workarounds in poorly documented and poorly maintained scripts. Technical debt grows and operations grow cumbersome over time. With lack of monitoring and observability, we tend to see validation issues picked up by downstream stakeholders. And ultimately, trust in the capabilities of the data team declines and frustrations increase across all teams. But around 2020, there was an attitude shift where the data engineer moves higher up the value chain. So no longer concerned as much with the nitty-gritty details of implementation, a data lifecycle engineer treats system components more like Lego bricks, and they become concerned with issues like security, data management, data ops, architecture, orchestration, and lifecycle management. Speaking of system components as Lego bricks, there seems to be about as many as there are unique Lego bricks. The number of platforms, services, and frameworks and best practices has genuinely exploded, especially over the last few years. And for a small to medium enterprise, it's not generally concerned with velocity, variety, and volume. Like Life in Australia, we face dual challenges. When do we specialize into data infrastructure? And are the available solutions appropriate for our current needs? So if a tool or best practice is oriented to solving problems around velocity, variety, and volume, then does it really suit our particular needs? And this is intended to be a story that highlights the relevance of focusing attention on infrastructure development and how we begin to think of orchestration. So at the start of the journey, we design a core data model allowing us to capture enduring business logic. And this is a simplified representation, just an idea of what we're looking at. We're making decisions around what entities and attributes we need to care about. Once we have that core data model, integration is about syncing data from and to multiple systems. So our initial design choice was to sync these data through the core data model. To maintain separation of the core model from external logic, we also had this integrations schema that we added, and a separate pipeline for each service extracted data into the integration schema, and they were then transformed into the core data model and back into the services. And it sounded simple, but in practice, we had something more like this. The process we designed involved unwittingly essentially 3 separate ETL, extract, transform, and load processes for each service. And since a copy of the pattern existed for each service, we actually had something more like this. And keep in mind, the core data model is still central, so it actually looks like that. So most obviously, this was something unnecessarily complex. Many of the ETL scripts performed similar tasks, but they're repeated and spread across many locations. Each of the pipelines is also an independent point of failure where data can be lost or corrupted. So suppose one ETL script flags a validation error when observing an unsubscribe, like this one up here. Did the cause originate from the script that produced it or from one of these other components? Logging was implemented independently in each process, so it can be a complicated task involving lots of inference. And there are also natural computational inefficiencies here arising from the order that the scripts were executed in and the time each process would take to execute. The rules for keeping data consistent and maintaining integrity were also spread across multiple processes. So decisions like how to handle edge cases for missed SMS records or triggering a missed incentive reward were scattered throughout the system. But what does all of this have to do with orchestration? I'll give you a definition finally of orchestration. What we just saw was a decentralized set of pipelines without orchestration. And in general, orchestration is a central hub for coordinating workflow and executing decentralized processes. And we have 2 nice quotes there about orchestration that I won't delay on. And what's the difference between orchestration and ETL? In ETL, we have a single linear process which performs 3 tasks: extract, transform, load. And in orchestration, there's a more flexible system to handle control. So an orchestration layer does extract and transform data, but it's also scheduling and executing tasks. It chooses when to extract tasks based on potentially complex conditions. They're typically viewed as directed acyclic graph of dependencies and only executed when needed. And the core idea is that orchestration provides a central location for things like handling failures and dynamically adapting to changes. It also typically offers monitoring, workflow visualization, alerting, and other observability tools like data lineage tracking. The list of capabilities is very appealing, but are we ready for orchestration? The central question in the engineer's mind should be, if we adopt this tool, will it reduce complexity or create more of it? So this is our question at Life in Australia, and we took an interim step towards it. And here we merge all those separate ETL processes into one in this interim step. We discarded the integration schema that we had and opted to store data in memory. We extract from all systems in one step, transform in one step, and load in one step. It's actually less distributed, and it's just an ETL script. So it looks like a step backwards. And it is, but it's also 2 steps forwards. Extracting data from all systems at once provides a cross-sectional snapshot, which is then logged as well. We can also use more custom logic to decide when certain steps need to be executed. And consistency rules are now handled in one place with a global perspective, which is central to the idea of orchestration. We can also flexibly accommodate situations where outputs are functionally dependent on the states of multiple different systems without spreading this logic across multiple scripts. And if inconsistencies can't be resolved, or if other errors arise, we can monitor this in the same process. So there's some of the advantages. And it's lower complexity and has some of the same advantages as orchestration, but it also has disadvantages. Without robust error handling and recovery, a single failure can terminate the entire process. Unrecoverable errors shouldn't have such widespread disruption. The scripts can grow quite complex as well. For example, using different SMS providers introduces new conditional logic, so new functions, new logic, and that poses concerns for functional scalability, adding more functionality over time. Also, while it's turned out to be faster than what we had before, it isn't near real time. Each component needs to execute in sequence. And we also perhaps aren't making use of industry best practices. It's a bespoke hybrid solution that we've created. But all is not lost. In phase 3, we seek to make optimal architecture choices for orchestration, and this is a foundation that we build on the phase 2 approach to get there. So it helps us organize the orchestration approach or understand what to do there. I'm going to skip forward on this slide to save time because I'm worried I'll run out. Just focusing on some of the results on our attention to infrastructure, we doubled the frequency of surveys without increasing resource use, which is pretty big. Improving panelist experience and streamlining the incentive processes as well, and having the ability to do more complex sampling strategies due to the new infrastructure as well. And that's it. Thank you.